This is property 5. I am going to prove the first one, and rest two you are going to do it at home. Let sine inverse x is y. So x is sine y. I will replace sine y with cos pi by 2 minus y. So according to the principal value, y lies between pi by 2 and minus pi by 2 inclusive. So here I can write down cos inverse x is equal to pi by 2 minus y. And then cos inverse x is equal to pi by 2 minus y sin inverse x. So we have here cos inverse x plus sin inverse x is equal to pi by 2. Now here we know y lies between minus pi by 2 and pi by 2 inclusive. Now to prove this also lies between 0 and pi. So if I write here minus y becomes minus pi by 2 and pi by 2. Now if I add pi by 2, and then I get and this is the principal value of this. Therefore, this is the proof. And here we can write here inverse. This I will take it as alpha, and this one I will take it as beta. I have to prove this. So x is tan alpha and y is tan beta. Tan alpha plus beta formula. In place of this, I will write on x. In place of this, I will write on y. 1 minus x by. So alpha plus beta. Now my question is, this alpha plus beta should be less than pi by 2 and greater than minus pi by 2. Principal value. So what I do? This condition is given here. I write this. This I get. This one I take it that side. We know cos A, cos B minus sin A, sin B is cos A plus B. So alpha plus beta lies between this. Because it is positive in this quadrant and this quadrant. Therefore, this condition is also satisfied. This you try to prove this at home. Amongst the three, I prove the first one. Here, let tan inverse x be theta. So x is tan theta. And this is given. So this is the formula that we are going to use to prove the first one. 2x by 1 minus x square. 2 theta is sin inverse 2x by 1 minus x square. And then theta is tan inverse x. This is the proof of first one. Since it is less than or equal to 1, this will be less than or equal to pi by 4. Because tan 45 is 1. So 2 theta, and this is the condition for sin inverse. For this, you are going to use the formula cos 2 theta is 1 minus tan square theta by 1 plus tan square theta, and you take tan theta as x. And for this, you use the formula tan 2 theta is equal to 1 minus 2 tan theta by 1 minus tan square theta. Just as you use this formula, for this you are going to use this formula, and for this you are going to use this formula. 2.2. Now I take x as tan A. This I will tell you. 2 tan A by 1 plus tan square is sin 2A. You know, sin 2A is equal to 2 tan A by 1 plus tan square. Similarly, y I take it as tan B. So cos 2B will be 1 minus tan square B by, you have studied in class 11. So by the property, this is 2A, this is 2B. Half into 2A is A, half into 2B is B. Now what is A? A will be tan inverse x. A is tan inverse x. And similarly here, B will be tan inverse y. Now this is the formula by the property. Property 1 is that 6 1. Tan inverse x plus tan inverse y is, because the condition is given here. So we have to prove this is equal to this. This question number 7, fourth part. So start with LHS. Tan inverse 1 is pi by 4. Now we would use the formula tan inverse x plus tan inverse y is this. Here you will find xy is less than 1. X is 1 by 2, y is 1 by 3. This is here x plus y 1 minus xy. This is 1 pi by 4 plus pi by 4, pi by 2. LHS is equal to RHS. It's important for this because just we have studied that 2 tan inverse x is equal to tan inverse 2x by 1 minus x square, and mod x should be less than 1. Here 1 by 3 is less than 1, so I use the formula here 2x by 1 minus x square, and after simplifying this I get here this one. Here cot inverse x is equal to tan inverse 1 by x. So 4 becomes 1 by 4, and then I am going to use the formula tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. Xy should be less than 1. X should be less than 1 and y also less than 1. So this is less than 1, this is less than 1. If I multiply, I get 3 by 16, which is less than 1. So I use this formula. This is equal to this. So LHS is equal to RHS. Property 8. I will prove the first one and then you will try this on your own. We know 1 plus tan square is x square. So I will take x as tan y. So y is tan inverse x. So left hand side, LHS. I will write this and replace x with tan y. Here what I get? Sin inverse tan y by sec y. 1 plus tan square is sec square. Root of sec square is sec. And this one I get tan by sec is sin y. And this is equal to y. And we know y lies between, since y is tan inverse x, y lies between pi by 2 and minus pi by 2. So here also y similarly, here also you will take x as tan y. 1 plus tan square sec square. So 1 by sec is cos. So cos inverse cos y is y, which is equal to tan inverse x. So y is tan inverse x. Therefore, sin inverse x by root of 1 plus x square is equal to this one. You will find here, we know that 1 minus Sin square y is equal to cos square y. 1 minus x square form. But here I have to prove sin inverse x. So I will take x is equal to sin y, because sin inverse x is equal to y. So LHS, I will copy this there and replace x with sin y. By 1 minus sin square is cos square. And this is equal to y. We know y is, therefore, is equal to y is. So we have finally tan inverse x by root of 1 minus x square is equal to sin inverse x. Similarly here, you are going to prove on your own. You take x as cos y and you prove it. Cos inverse x is equal to y. You are going to prove this on your own. Property 10. How to convert sin inverse x to cos inverse x and cos inverse x to sin inverse x. I will start from here. Let sin inverse x be equal to y. So what I get from here? X is equal to sin y. And we know that y lies in the first quadrant because it is given the value of x 0 to 1. Now from here, what is cos y? Can I write this 1 minus sin square y, and this will be positive because in the first quadrant cos is also positive. This can be written as cos y is equal to 1 minus x square, sin y is x, and then finally we have here y is equal to cos inverse 1 minus x square. That is, what is y? Y is sin inverse x. And right here, sin inverse x is equal to cos inverse 1 minus x square. This is the formula. Similarly, you can prove this. You take here, let y be cos inverse x. This one. And if you combine these two, you will get this. Because cos inverse here, you can write, I can write on here, cos sin inverse x. Cos sin inverse x is equal to 1 minus x square. Here, sin, I will bring it here. It will be sin cos inverse x is equal to root of 1 minus x square. I combine this and I get the third. So I will prove the first one. Rest you are going to prove. Let sin inverse x be A and sin inverse y be B. So what I get from here? X is equal to sin A and y is equal to sin B. So from here I can get cos A is equal to 1 minus sin square. Sin square means x square. And cos B is equal to 1 minus sin square B, 1 minus y square. Now I'll start here. I write here sin A plus B formula. It is sin A cos B plus cos A sin B. Sin A is x, cos B is 1 minus y square, sin B is y, and cos A is from 1 minus x square. So A plus B is equal to sin inverse x 1 minus y square plus y 1 minus x square. What is A? A is sine inverse x. Sine inverse x. And what is B? B is sine inverse y. And this is equal to sine inverse x. This is the first one. Here you use the formula sin A minus B. Here cos A plus cos B. Here cos A minus cos B. Because we are going to use this formula here. Why? Because condition is this. 2 into 3 is 6, which is greater than 1. So LHS is tan inverse 2 plus tan inverse 3, and this is equal to pi plus tan inverse 2 plus 3 pi 1 minus 6. Principal value you have learned how to find. So this is minus pi by 4. This is 3 pi by 4, and therefore LHS is equal to RHS is equal to 3 pi by 4. 8th exercise 2.2. So LHS is this. I need to convert cos inverse to sin inverse because the result is in sin inverse. We know cos inverse x is sin inverse root of 1 minus x square. We have proved it. So 1 minus 9 by 25, I get this. Now the formula sin inverse x plus sin inverse y is sin inverse x root of 1 minus y square x square. After using this formula, I get sin inverse 20 plus 36, 56 by 65. So LHS is equal to RHS. 8/3. First, we know 2 tan inverse x. This is the formula. X is 1 by 2. So I get 2 tan inverse 1 by 2 is this. And cot inverse x is tan inverse 1 by x. So cot inverse 3 is tan inverse 1 by 3. Now this value, I'll put it here, and here I will write tan inverse 1 by 3. The formula tan inverse A minus B 1 plus 4 by 9, and then I get here tan inverse one by, this is 4 by 9, it is 13 by 9, 9 by 13. Property 12, the first one I will prove. I'll take sin inverse x as y. This is also given here. So in place of x, if we write y, I can write here minus 1 by 2. X is sin y. So can I write from here that y is less than or equal to sin 30? Sin 30 is 1 by 2 minus pi by 6. And if I multiply here 3 into 3 into 3, what I get? Minus pi by 2. A typical inverse condition for sin inverse. Now, What is sine 3y? We know it is 3 sine y minus 4 sine cube y. So, sine 3y is equal to 3x, sine y is x. Here, sine y is x minus 4x cube. So 3y is equal to sine inverse 3x minus 4x cube, and then y is equal to 3 sine inverse x is equal to sine inverse 3x minus 4x cube, and we know that's 3y